Hi everyone, today we're going to look at inverse trig integrals, or first we're going to look at the derivatives of inverse trig functions, and we're going to see what integrals match those derivatives. Okay, so first of all we want to see what does the arcsine function look like. Okay, so we want to look at it as a function. So here's our sine function. Okay, so I'm going to just draw our sine function like this. So I'll do a different color so you can see a little bit better. Okay, so we're going to draw our sine function, just with one period of sine, and sketching in our axes here. There's positive y, there's positive x going in this direction. Okay, and if we want to find the inverse or arcsine, what we can do is we can just flip the x and y's. So I'm just going to rotate this and flip it. There's lots of ways to do it, but I'm going to just rotate and flip like that. And notice that what I end up with is my x is pointing in the positive direction, positive y direction. I have my y's pointing in the positive x direction. So I've done an inverse of that original operation, okay, or the inverse of that original function. Now, if we take a look at this function here, okay, this is not a function. So in order to make this a function, what we need to do is we need to have it pass the vertical line test. To do that, we're going to change the range of this function. So the range of this function, or the angles, we're going to change it to that section there. Okay, we're going to get rid of the blue. So there represents my inverse sine function, where that represents positive pi over 2, that represents negative pi over 2. Okay, so that's not a very nice looking function, but that's essentially how we get it. We switch the x and y axis to get the graph to look like that, and then we trim that graph to make it into a function. So there is the inverse sine function. So I'm just going to redraw this a little bit nicer so that looks a little bit more clear. Okay, so there's my function here, and I'm going to have my graph like that. Okay, so there's the vertices of the graph. That's 1, negative 1. Okay, so that's now our ratio along the x-axis, and along the y-axis now represents the output or the angle. Okay, so there's my inverse trig function or inverse sine function. And notice that the domain is the output, the old output from negative 1 to 1. My range though has to be trimmed so that we can make it a function. So we'll only take it from negative pi over 2 to pi over 2 to trim that function to make it a function. We could do the same thing for cosine here. Okay, so there's my x and y. So there's my y in the positive direction. There's my x's in the positive direction. Okay, I'm gonna just sketch this graph here like this. Okay, and I'm gonna just do a transformation on it. I'm just gonna switch the x and y's on this. Okay, so once I flip the x and y's on this, I have now done the inverse. Notice my positive y is pointing in the positive x direction, and the positive x is pointing in the positive y direction. So again, we don't pass the function test. Okay, it doesn't pass the vertical line test. So we have to trim this function so that we can define it as a function. Okay, so we're going to trim this function from here to here, and that's going to be our function. Okay, so there's 1 and negative 1, my inputs or my output for the cosine, and I'm going to go from 0 to pi. Okay, so that represents then the new domain and range of the inverse cosine function, or the arc cos function. Okay, so that's what it looks like. So again, what I'll do is I'm just going to redraw this so it looks a little bit nicer. Okay, so it looks like this. Okay, there's going to be from here to here. Okay, so that's 1 and negative 1, and it goes from 0 to pi. Okay, so there's my arccos function. I probably should do the tan as well. So the tan function, okay, is going to look like this. I'm just going to draw one period of tan. It's going to look like this. So if I switch the x and y, so this represents tan x. So y equals. So if I want to draw the inverse function, arctan x, well, the y values have to be, I'm going to have asymptotes here and here. Okay, at pi over 2, negative pi over 2. Okay, so my output angles have to be restricted between those two. So the output is the same as or similar to sine, arc sine, but these are going to be these are asymptotes, so we're not going to touch those asymptotes. So there's my arctan function looking like this. Okay, my domain, my input is nice because I can have any angle I want. Okay, so my domain works out to be x is between, well, my input could be a ratio of negative infinity to infinity, and my range is going to be not including negative pi over 2 to pi over 2, and again, not including because those pi over 2s are asymptotes. Okay, so that we've established the inverse sine, inverse tan, and inverse cosine functions.